Good afternoon, ladies and gentlemen, and welcome to our second lab video. In this video, we're going to be talking about measuring volume and density of a liquid. In this particular lab, we're going to be measuring the volume and the density of two different liquids. The first liquid is going to be plain water, H2O. Our second solution, solution B, is going to be a combination of water plus a white salt-like substance you see here on the screen. Let's get started. First, we're going to measure 5 data points of volume using our graduated cylinder. We're going to start first, though, by getting the mass of an empty beaker. This is a 100 milliliter beaker. I'm going to take this beaker, I'm going to put it on my scale. Every scale has a zero or a tare function. I take the beaker, I put it on the scale. This scale tells me this beaker is 59.4 grams. I hit the tare button, and that brings it down to zero. It's important to start with zero, or your graph will be skewed by the amount of the weight of the beaker. Next, I'm going to go and take the graduated cylinder, and I'm going to measure out 20 milliliters of liquid. I take my beaker, and I start to pour it through the top here. I can get pretty close to where I want to go, but then what I want to do is I want to get down, and I want to look from the side here at the markings. Sometimes it's helpful to put your hand in front, as you can see I'm doing here. I know it's hard to see on the camera. According to this, I'm slightly lower than 20 mils. So I'm going to go ahead and put a couple drops in, and then I'm going to repeat the process. Remember, we are looking for the meniscus, meaning the bottom of the little arc there, to measure. I continue taking a look here, and it looks like I'm right at the meniscus for the 20 milliliter mark. I'm going to go ahead and take my 20 milliliters of liquid, and I'm going to pour it directly into the beaker here. Now you're going to notice that I want to get as much of the water as possible, as that's going to affect the mass. I got for this one 19.2 grams. I'm going to put that here on my first spot. Let's do the next measurement. This time, I'm going to do the same exact thing, except for I'm going to leave this in the beaker. So I'm going to go ahead and pour some in. Of course, try not to spill on myself. This time, I obviously got a little bit too much. So I'm going to grab my pipette, and I'm going to squeeze out some of the liquid. There, you can see I'm squeezing it out here, trying to get the mark as close as possible. Now, once I get it close, I'm going to lean over, and this one looks like it's right at the meniscus. So I'm going to add my 20. So far, I've had 40 milliliters into my cylinder. Here, I'm going to have 37.9 for my next measurement. I'm going to do the same thing again for the next 3 measurements, and when we come back, I'll have the full data table. As you probably can see now, I have a beaker. You're going to notice that that beaker is definitely over the 80 milliliter mark on the beaker. In fact, we never measure from the beaker because the beaker is extremely inaccurate. Going to our board here, we can see our graph as shown on the screen. We're going to need to graph the data on our graph. There's a couple of ways of doing this easily. First, I'm going to draw a line up, just kind of an axis here along the different points that are going to allow us to see where the graph actually should go. On a regular graph paper, these would be shown, which makes it easier to see. I'm then going to go ahead and use my standard graphing procedures to put the points on the graph. 37.9 is about here. 56.8 is about here. 75.0 is here. And finally, 109.4 is over here. Now that I've got my points on the graph, I want to draw what's called a line of best fit. I'm going to go ahead and I'm going to draw a line which goes through the points the best possible. You'll notice the graph it has a nice straight line, but it doesn't necessarily go through all of the points. The idea is that you want to pick points they're going to fit on the graph the best possible. Now, in this particular case, you'll notice that the line is a little skewed, and that's perfectly fine. Now, to get the next part of this done, we want to pick 2 points on the graph that we want to use. What you want to do is you want to pick 2 points that are on the line. I'm going to pick this point here and this point here. I'm going to call this x1, y1, and I'm going to call this x2, y2. I'm going to use those 2 points to calculate the slope. That's this point here and this point here. To calculate the slope, I'm going to go ahead and plug the information in from our previous section. Here, our x1, y1 is going to be 40, 37.9, and our x2, y2 we picked from our graph earlier is going to be 80, 75.0. Now, I'm going to go ahead and plug those data points into my graph. Here, I've got y2, 75.0, minus y1, 37.9. On the bottom, I have x2 minus x1. When I grab my calculator here, 75 minus 37.9 is 37.1, and that's 40. This is going to be grams and milliliters. Then, when I divide the two numbers, I get a slope of 0.92 grams per milliliter. That is the density of our water. Now, of course, that density is a little off. We expect that water to be 1 gram per milliliter. Unfortunately, the difference is due to the way the fact that the measurement works. There are a lot of errors that occur due to the way the graduated cylinder works. This would work a lot better with more specialized glassware, such as volumetric glassware. For our second sample, sample B, we're going to make a mixture of salt and water. I'm going to start by taking this and pouring it back into my beaker. The general concept is you want this to be as dry as possible. Again, I'm going to put this on the scale, and I'm going to hit the tare button again to make sure I zero out the weight. Next up, I'm going to take this and I'm going to scoop a significant amount into the beaker. I'm going to go ahead and pour that in. My goal is I want the water to get really cloudy, and I'd like to have some of the salts remaining at the bottom. I want to give this thing a good stir for just a second to give it a chance to dissolve. To check whether it's all dissolved, you can lift it up and look at the bottom. I notice that there is a little bit of solid sitting at the bottom, but I bet some more can dissolve. Let's put some more in. By the way, a scoopula is not the way to stir things, but it certainly works in this application. As you can see, as I put the salt in, it becomes extremely cloudy. Again, double checking. It certainly looks like I can add some more. The water's still not completely done. Let's put some more in. As I stir it one last time, I can see there's salt sitting at the bottom. This solution is now saturated, meaning it contains as much salt as we possibly can dissolve into the container. I'm going to repeat the same process I repeated last time on the measuring process. I'm going to start by measuring 20 milliliters. Again, like last time, you want to make really careful that you look through the bottom and you check for that meniscus to make sure we're right where we want to be. I'm a little bit too low, so I'll put some more in there. Now, looking at the meniscus, I'm still a little bit low. Let me grab a little bit more with my pipette and squeeze a couple drops in. Doing the same thing, that's 20 mils. I'm going to take this and I'm going to pour it in. For this one, we have 20.06. Repeating the same process, I'll get the next measurements. As we finish up with sample B, you now can notice that the sample is as we see here. Let's go ahead and do our graph now. Again, like last time, I'm going to put little lines going up to assist me with the graphing process. Here we have 60, we have 80, and we have 100. Now there are limitations to graphing due to the way the graph is structured, but we'll do our best. Our first one is going to be 20.06. Our next one is going to be 39.8. Our next one is 59.6. Our next one is 78. And finally, 99.1. Like last time, I'm going to make a line of best fit. That one's a little bit off. Let's try it again. As you can see, it's important to try to get all the points in as possible. That's a little bit better. Now you can see that the line goes through the points as best we possibly can. Like last time, I'm going to pick 2 points to do the slope. This time, I'm going to pick the first point, which is going to be 20.6. And our second point is going to be the final point, 199.1. Going through the same procedure as last time, this is going to be x1, y1, and x2, y2. Going through and setting things up, again, y2 minus y1 over x2 minus x1. Then I'm going to go ahead and do some math here. 99.1 minus 20.6. And at the bottom, 100 minus 20. Going through for our next part here. Now you can see because y is grams and milliliters is at the bottom, I put those in. And then dividing the two values, I get a slope of 0.98 grams per milliliter. Now you're going to notice something about our graph here. Generally speaking, adding a salt compound will change the density of the solution. But the limitations of our lab experiment here, especially with the volume, doesn't show a dramatic change. This is because salt and water have similar densities. In fact, water is slightly more dense than salt is initially. But as you can see here, we were able to find the property density from simple math and simple solutions. Given that, we're now at the end of lab number 2. As always, if you have any questions, please let me know during class, and have a great rest of your day. Goodbye, everyone.